Welcome to part 2 of this lesson. Let's look at the question that we've been given here. It says solve sine of x is equal to the square root of 3 on 2 for x is an element of 0 to 4 pi. Now hopefully what you can notice is different here from part 1 is that our domain is different. Here it's 0 to 4 pi. In the previous part we had only looked at domains from 0 to 2 pi, but all the questions on this page here, 0 to 3 pi, here it's negative 2 pi to 2 pi, here it's negative pi to pi. We have strange domains. So domains that aren't your conventional 0 to 2 pi. So we need to know how to deal with these when we're given a strange domain. To help us visualize this question right here, let's just look at a PowerPoint right here. And I've entitled this, when solving trigonometric equations, always look at the domain to determine the amount of solutions. So what exactly does that mean? Well, here's our question. Let's draw our axes. Then let's draw sine of theta. If we draw just one period, we know one period is 2 pi, but as you can see here, my domain is 0 to 4 pi. So that means I'm going to have to draw another period here, and that now takes me to 4 pi. Now, when I draw in this right here, so y is equal to the square root of 3 on 2, as you can see, I have 4 solutions. It hits the line 4 times. There are 4 points of intersection. So the amount of solutions I will have to this question is going to be 4. And that's really important. So again, we're going to be using the same technique that we used in part 1, but I just want to get your head around that when our domains are different, our solutions are going to have a different amount. We're going to have a different amount of solutions. So in this case, we're going to have 4 solutions as opposed to just 2. Okay, so let's bring this back up and let's answer this question. So again, it's always nice just to think about things in terms of your unit circle. So if I've got sine, and I know that I'm dealing with my y-axis, and then I've got the square root of 3 on 2, so that means I'm up here. So that means I'm dealing with here, and I'm dealing with here, which means I'm looking at my first and my second quadrant. That's where my solutions are going to exist. Then what I'm going to do is I'm going to find what my reference angle is going to be. To find my reference angle, you might like to use your special triangle, like this. This is 2, this is 1, this is the square root of 3. Because I'm dealing with sine, it's opposite over hypotenuse, which means I'm going to be looking right here at pi on 3. So that means pi on 3 is going to be my reference angle. Now I'm going to be figuring out my values of x for which this occurs. So I'm using x because that's the pronumeral that was given to us. And you can clearly see that it's going to be this one, and this is simply pi on 3. It's in my first quadrant, pi on 3. And then in my second quadrant, we're looking at this angle right here. In my second quadrant, that's going to be 2 pi on 3. But this is where it becomes interesting, everyone, because we have only gone 2 pi around our circle. We need to go 4 pi around. So that means we're going to have to make another loop around our circle. So now I'm going to go around, and now up here. And as you can see here, I've come back to this point right here, and I have to figure out what it's going to be. To figure out what this is going to be, I can just take this value right here, and I can plus it by 2 pi. And then I'm going to have to make another circle around. How can I do this? Let me rub this one out. I'm going to have to go around again, around, and then stop here. Because remember, it's till 4 pi. I need to make 2 loops around my unit circle. To find that one, I'm going to take this one and plus 2 pi to it. And that's where I stop, because it's 4 pi just means go around it twice. Now I'm just going to have to do some calculation, so nothing too tricky here. Let's do first this one. So I'm going to take pi on 3, and I have to plus 2 pi to it. Now I need to make sure my denominators are the same, and for that to happen, I'm going to have to get 6 pi on 3. 6 pi on 3 is the same as 2 pi, so that's going to be 7 pi on 3. So that's going to be that one right here. And now, let me change my color. I'm going to do the same thing here. So now I've got 2 pi on 3. Whoops, I did not mean to do that. Get rid of that. So I'm going to take 2 pi on 3. Again, I'm going to be plussing 2 pi to it, which is just 6 pi on 3. And that's going to take me to 8 pi on 3, which is going to be this one right here. You obviously don't need to put in these arrows, they're just to help us. Those are going to be our answers. just like that. So that's how you approach a question like this. Always be looking at the domain to determine how many solutions you're going to have. Let's go into our next one now. This one's going to require a bit of rearranging before we get stuck into it. So I'm going to say that this is tan of theta. I'm going to minus 1 and then divide by the square root of 3. And now I've got this. Once I've got this, I need to figure out what my reference angle is going to be. Remember, use that little trick I told you. Think of tan as gradient. This is the lowest gradient I can get, which I know is going to be pi on 6. So again, the way I like to think about it in terms of my reference angle, so I'm looking in my first quadrant, I've got 3 reference angles, here, here, and here. And because tan is just a gradient, I've got this one, I've got this one, and I've got this one. I know this is my lowest one, so it's going to be pi on 6. Remember, I'm ignoring that sign as well. Now, it's negative, so I know tan is going to be negative here. Let's see if I can draw this nicely. Here and here. That's as good as it's going to get, which is going to be my second and my fourth quadrant. So that means theta is going to be 5 pi on 6 and then 11 pi on 6. Now here's the interesting part right here. It's 0 to 3 pi. I've only gone 2 pi around at the moment. So that means I need to go another pi around to get to 3 pi. So 2 pi plus pi is 3 pi. Now remember, pi is just 180 degrees. So that means I just go around pi more times, which is going to take me to here. So let's just really step back for a moment. I'm going around pi more times. So I need to say, all right, where do I hit negative 1 to the square root of 3 again inside this pi right here? And that's going to be right there, right here. So that means I'm going to take this one right here and I'm going to plus onto it 2 pi. When I do that, I'm going to go 5 pi on 6 plus 2 pi, which will be 12 pi on 6. That's going to end up being 17 pi on 6. And that is going to be my answer. Get rid of this. And that's how we would approach that question. Perfect. All right, let's go on to our next one. All right, this is going to be an interesting one. The reason why it's interesting is, as you can see by my domain, I'm going backwards as well as forwards, which is always fun. Okay, how are we going to do this? We're going to go sine of theta is equal to, now I have to rearrange it first, but rearranging is really quite easy. I'm going to minus the square root of 3 and then divide by 2. If you wanted to, you could come down here first. I'm dealing with sine, so that's my y. And then it's going to be negative the square root of 3 on 2. Negative the square root of 3 on 2 is going to be down here. So I'm looking at my third and fourth quadrants. I have to figure out what my reference angle is going to be. You might like to just quickly draw a triangle, your special triangle here. Go 2, 1, the square root of 3. If its sine is opposite over hypotenuse, so it's going to be this one right here, pi on 3. So it's going to be that. So now I'm going to go theta is equal to, now I have to go backwards, so I'm just going to leave 2 places blank. Here is going to be, in my third quadrant, 4 pi on 3. And then in my third quadrant, 4 pi on 3. In my fourth quadrant, 5 pi on 3. So just so you know what happened there, what I did is I went here and here to get these two, but now I have to go backwards. So I'm going to have to go here to here. So what is this going to be? Well, if we think about it for a moment, it's clearly going to be negative pi on 3. And then I'm going to have to go here to here, which is simply going to be negative 2 pi on 3. Those are going to be my answers, just when I think about it. It's pretty clear that's what they're going to be. But if you wanted to, another way to go about these would be to go, all right, I'm subtracting 2 pi here, and I'm subtracting 2 pi here to get those. So if I take 4 pi on 3 and I subtract 2 pi, which is 6 pi on 3, I'm going to get negative 2 pi on 3, which is what I said we got down here, negative 2 pi on 3. And then if I took 5 pi on 3, 5 pi on 3, and I subtracted 6 pi on 3, I'm going to get negative pi on 3, which is what I said you'd get there. negative pi on 3. And those are our answers. So that's how we approach it. Perfect. So now that we've done those, let's now come to our final one here. As you can see, our domain is weird, as always. Let's just get the red out. Alright. First thing I'm going to do is just a bit of rearranging here. So I'm just going to divide both sides by the square root of 2 here, which will make my life a little bit easier. And then once I've done that, I would come, whoa, daisy. Sorry. Sometimes it does that, just freaks out. Because I'm dealing with my cos, that means I'm looking at my x. It's positive, so it's going to be over here. So I'm going to be looking at my first and fourth quadrants. First and fourth quadrants. Then once I've done that, I'm going to have to figure out what my reference angle is going to be. As soon as I see 1 on the square root of 2, I know my reference angle is going to be pi on 4. I just know it. And then once I've done that, the next thing that I'm going to do is I'm going to say theta is equal to, now this is where you have to be careful. You have to look at your domain and be really careful about it, because I feel what most people would do here is say, all right, I've got 1 here and I've got 1 here. So this angle here is going to be pi on 4 in my first quadrant. And then in my fourth quadrant, it is going to be 7 pi on 4. So pi on 4, 7 pi on 4. I feel that's how many people would think about it. They'll say my first quadrant's pi on 4, my fourth quadrant's 7 pi on 4. But immediately you can see 7 pi on 4 is outside of my domain. So that means we don't include it. We don't include that one because we're stopping at pi. We're not going past pi, and that thing went past pi. So that means we stop there. That pi on 4 is our answer for when we're going pi. Because from here to here, there's only one answer at pi on 4. But remember, there's also negative pi. So we also have to go back. So we need to figure out where the answers are going to be from negative pi. And obviously our answer is simply going to be here. And that's just going to be negative pi on 4. And that's all we're going to do there. It's just negative pi on 4. So it's negative pi on 4. And just like that. So as you can see, there's going to be some instances right here from 0 to 4 pi where we get more solutions because, you know, we include more solutions when our domain is bigger. But also we might get a smaller domain, which means we have less solutions. And you just need to be really careful that you're staying within the domain, otherwise bad things will happen. Okay, hopefully all that made sense. Let me just quickly highlight my answers here. And there's only one more, oh actually there might be more than one more part. There's going to be another part to this video, to this lesson, and hopefully it will help you. So I'm just going to highlight my answers here. So I will see you in the next part of this lesson. Hopefully you found this helpful, and you know, you just appreciate the fact that when our domain is different, the amount of solutions we get is going to be different as well. All right, I'll see you in the next lesson, next part of the lesson, same lesson.